In this video, I will show you how to calculate a change in length. So let's see, Diana works in a building that is 130 feet tall. She is outside looking up at the building at an angle of 37 degrees from her feet to the top of the building. So let's draw that so far. So here's the ground, and here's the building, and here is Diana. Okay, so let's draw a line from Diana's feet to the top of the building. So the building is 130 feet tall. Okay, so this is 130. All right, 37 degrees from her feet to the top of the building. So that means we have 37 degrees right here. If Diana walks forward and her angle looking to the top of the building changes to 40 degrees, how much closer is she to the building? Well, we're talking about how far Diana is from the building. So let's start by finding out her distance right now. So let's use x to represent her distance now. Okay, so distance now is equal to x. Distance later will equal y. We'll get to that in a minute. So let's use sine, cosine, or tangent in order to find x. I like to use the acronym SOHCAHTOA. SOHCAHTOA. This reminds me of the three definitions of the trig functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what do we have here? Well, this is the 90-degree angle, and across from that will always be the hypotenuse. And if I were to draw a circle around this angle and draw an arrow, I'm pointing now at the opposite side. The other side is called the adjacent side. Uh-oh. No, that's okay. So for this problem, we are going to be dealing with opposite and adjacent. Opposite is 130. Adjacent is x. The hypotenuse has nothing, so I'm going to ignore that and focus on the fact that I'm dealing with opposite and adjacent. Which trig function is that? Well, that's going to be the tangent function, because tangent is opposite over adjacent. So let's go ahead and set up the tangent function. So we can say that tangent of the angle is equal to opposite over adjacent. So that's 130 over x. When the variable is in the denominator, you swap these. So you're going to get x is equal to 130 over tangent 37. And this is something we can just put in our calculator. Alright, so 130 over tangent 37. Alright, 172.5. Okay, so that is her original distance. So let's change the situation and find the second distance. Alright, so most of this picture is going to be the same. but this time she's just going to be a little bit closer. So here's the building again. And here's Diana. Okay. And so they said they want to know how the distance changes if the angle looking up to the top of the building changes to 40 degrees. So if this angle is now 40 degrees, all right, of course the building is still 130 feet tall. All right, that hasn't changed. So now we're going to find y. Okay, so y will be the new distance that she's walked. So the formula is going to be the same. We're still dealing with opposite. You know, this side is opposite, and this side is still adjacent. So we're still going to use the tangent function like we did before. But this time, instead of being tangent of 37, it's going to be tangent of 40. All right, opposite over adjacent is going to be 130 over y. When the variable is in the denominator, you swap these. So you're going to get y equals 130 over tangent 40. And this is something that you can simply put in your calculator. So 130 over tangent 40. So we're getting 154.9. So that's 154.9. So if we want to know how much closer she is, we just have to subtract these. All right, the original distance is 172.5. The new distance is 154.9. So how much closer is this? We're going to subtract. So how much closer? Okay, how much closer is she? 172.5 minus 154.9. And let's just drop that into the calculator. 172.5 minus 154.9. So she is 17.6 feet closer. Okay, so that's why this is going to be the answer right here. Ta-da!